A team of cosmologists announced that they had made a startling discovery. What they claimed was evidence of the gravitational waves created in the immediate aftermath of the Big Bang. The news was hailed as potential proof of the inflationary theory, which in turn could support the hypothesis that our universe is actually part of a multiverse. But since then, a re-examination of the data by scientists at Princeton University concluded those original findings might be way off. They say those gravitational waves might not have been detected at all. Cosmologist and theoretical physicist Marcelo Gleiser examines the multiverse hypothesis and many other of the thorniest questions facing scientists today in his new book, The Island of Knowledge, The Limits of Science and the Search for Meaning. He joins us from Dartmouth College in New Hampshire. Marcelo Gleiser, welcome to Day 6.
Well, thank you very much for having me.
Your new book is about the limits of human knowledge. Will we ever be able to know if the multiverse hypothesis is true?
Well, you start with the heavy one already, huh? Well, I don't think so. So what is the multiverse? So let's unpack that a little bit, right? So the idea is that our universe, the stuff, everything that we see around us, our galaxies, everything, stars, is not the whole story, that our universe is just one among many, many others, possibly infinitely many others, universes. And so the question is, how can we tell? Can we ever travel outside our universe to see those other guys? And the answer is we cannot. Can we receive light or some sort of information from the other universe? And the answer is, again, we cannot. So we can never be 100% sure that something like a multiverse exists. All we can have is very indirect evidence that perhaps in the past history of our universe collided with a neighbor, sort of like two soap bubbles colliding. Mm-hmm. And when those things happen, the bubbles kind of shake a little bit, and that shaking of our universe would be translated into shaking of the matter that exists inside and the radiation, and that would give us some indirect evidence for that collision. And you believe it or not, people have been looking for that in a pattern of what we have. We have a whole microwave radiation spread around the sky, but we have not found anything.
So it sounds like it's possible, perhaps, if we have that, to acknowledge that there's a neighboring universe. But how many universes does it take to make a multiverse?
Exactly. So strictly speaking, you cannot prove the existence of a multiverse. But what people say is that, hey, if you have more than one, then you can have many. But that's an extrapolation. So if you want to be kind of conservative, the point is the multiverse has created a point of rupture between the usual way we do physics and this kind of more metaphysical way of thinking, where perhaps there are scientific ideas that we can never be sure of.
So if the multiverse can't be observed or proved, is it still science?
Well, I personally don't think it is science, at least not science in the way we are thought to do science, because science behaves within a certain code, and the code is very simple. You can have a very crazy hypothesis, but as long as it is testable, as long as somebody can observe or go to the laboratory and test it, then you can either reject it or you can accept it. Now, what do you do with a hypothesis that can never be tested and what we call, the fancy word is falsified, right? Well, I think that is not science as we understand it. And so there is a real split right now in the scientific community between people that say we should stick to the code and others that say, no, let's let our ideas kind of run wild and see how far we can go with it. And honestly, I think that's somewhat irresponsible because people get confused. And nowadays, there are so many disputes about the credibility of science with global warming, etc., that we have to be very precise, very careful how we make statements to the public about what science can and cannot do.
Well, do you think that there's a problem in the way scientists report their findings, the way the media reports their findings, the way people extrapolate from what they hear when it comes to something like the multiverse and the reality or lack of reality of its existence?
Yes, I think there is a problem. And unfortunately, a lot of this problem is being caused by some very famous scientists. Some people like even Stephen Hawking and Lawrence Krauss and other people, they have made public statements about the multiverse exists, or another good one is we know what the Big Bang is, we now have a theory that explains everything. And those statements are simply not true. We do not know any of these things. They're all very much open questions. And so, when people like that make these statements, the public is going to say, well, if those authoritative scientists are saying that, we should believe it. And the point I'm trying to make is we should not believe it. We should be very careful about what science is able to do and what science is not able to do. And one thing science cannot do is answer all questions.
Well, and as a matter of fact, it's not just scientists who like to conceive of the multiverse. When you're talking about these unknowables, it starts to sound like something akin to religious faith. Do you think it's fair that people are drawing that parallel?
I think that's unavoidable that people draw that parallel because you say, aha, you can't understand all there is to understand. And the reason I call my book The Island of Knowledge is that around the island of knowledge, there is this ocean of the unknown. And within the ocean of the unknown, there are things which are unknowable. And people are going to say, that's where I find my God. And I'm going to say to them, good for you. But the point is that you do not need to reach out into supernatural belief in order to justify that we can't understand everything about the world. In other words, you cannot create what we call a God of the gaps to fill in the lack of our understanding. Say, oh, we don't understand this, that's because God did it. That's a very dangerous position to be in, to rest your faith in, so to speak.
But some of these things, and I would think the multiverse is among them, at least personally, it engages the imagination. I would imagine it's harder to kill the desire for this to be true when it's something that contains, I guess, so much possibility.
Absolutely. And, I have to confess that I love the idea of the multiverse. I think it's very compelling because one of the things that it does is to say this, our universe is not special. It's just one universe among many others. And perhaps as you look around at other universes, the properties that we find here of our electron mass or the strength of gravity or the speed of light, those properties may even be different in other universes, which shows that there's nothing so special about ours. It's just one among many, perhaps infinitely many. And I like that idea of cosmic democracy, but liking an idea doesn't make it real.
Marcelo Gleiser, it's been a pleasure to talk with you. Thank you so much.
My pleasure. It was great. Thank you.
That was Marcelo Gleiser speaking to us from Dartmouth College in Hanover, New Hampshire. His new book is The Island of Knowledge.
Marcelo Gleiser, I have just gotten to know. What is the name of your book? A Tear at the Edge of Creation. A Tear at the Edge of Creation, a fabulous book. And I'm so happy to be introduced to this work and this writing. Will gave the evening this lovely, evocative title, which I was thrilled to take on, The Mystery We Are. And I want to start with that phrase. Actually, I would like to start with you, Marcelo. You grew up in Brazil. You've written that growing up in the tropics is a blissful portal into the natural world. I wonder if you could just say a little bit about how you trace back to your earliest life your sense of mystery as something thrilling and animating and also eventually linked to science.
I grew up in Rio in particular and right in front of the ocean. So it's impossible not to be amazed by the enormity of nature when you have that huge, beautiful Atlantic Ocean in front of you. And I was lucky that my grandparents had a house in the mountains about 2 hours from Rio, which we used to go to, which is part of what is called the Atlantic Forest, which is this incredibly luscious, full of life, orchids and bromeliads exploding everywhere. And that enchanted Charles Darwin when he went down there, on the Beagle, and he talked about this power of nature. So I think from a very early age, I was just mystified by the beauty of this. And I wanted to understand how was that all possible, And initially, I looked for answers, so to speak, through religion. I grew up in a Jewish family, and I had a very formal Jewish education And then I didn't feel satisfied with that. I wanted something different. And then for my bar mitzvah, I actually got an autographed picture of Albert Einstein, who was in Brazil in 1925, and he was hosted by a grandfather.
Right.
So I was blown away by that, and I decided to know who was this man.
He was visiting the Jewish community there, which is, I think, a part of Einstein's life that we don't hear as much about.
Yes, exactly. So Einstein, after he became a superstar, he went down to South America to raise money for the Zionist cause. So the Jewish community is all kind of galvanized by this, and it turns out that his host in Rio was my grandfather, and they took a picture together, and they both autographed this. And that became my little altar, this man. And so I would worship, and I would learn about him more and more. And I said, I want to do this. I want to. And one thing that he always wrote about was about the mystery of nature as the driving force behind science and scientific curiosity. And to me, that spoke to me directly, that science was not so much about finding all the answers, but actually about courting with the mystery of the unknown. And I still feel that way.
And Marilyn, you grew up in Idaho, which you describe also as a place of more austere but intense beauty. So I want to ask you the same question. How do you trace the roots of your sense of mystery also as something that came to be an animating force for you as a novelist and a writer?
Well, my grandparents had a house in the mountains, not not terribly far from where I lived. It was in the western side of the Rocky Mountains, near Canada, and the proportion or the disproportion of nature on the one hand and human settlement on the other was really striking. As a child, I grew up with the idea that human beings were a fairly trivial presence in the environment, and that the mountains, you could hear them all the time. You could smell them. There was pine in the air or snow or whatever. My grandparents had a house built actually by my great-grandparents, which was modern by the standards of the late 19th century, and so it had a sleeping porch. You were supposed to sleep out there so that you wouldn't get tuberculosis. And it was amazing because at night you would hear the mountains, you would hear coyotes, and there was no other light. There was no sense of human presence aside from my grandparents' house. And for me, because of the atmosphere of my own childhood, this became very, very deeply associated with theology for me, with religion, with the idea of the presence of God. And I think that the sort of fusion is characteristically American in a lot of ways. When I went to college in New England and read the Transcendentalists, I thought, exactly,
So in your recent writing, each of you is driven from different directions by an observation that we have been working, thinking, acting on outdated models of reality, a limited conception of humanity and of the universe, and even of science. I mean, Marcelo, you talk about growing up, as you became interested in science, fascinated with this idea of unification, which was an idea of Einstein. And you talk about going to grad school following this intellectual holy grail. Mm-hmm. But you don't quite see it that way anymore.
Right. So just to clarify, right, one of the grand goals of modern physics is to build a theory of everything, a TOE, not a very beautiful name, but a theory of everything that would, in principle, explain all that we can observe of nature in terms of a single force, so to speak. And it's a very beautiful idea. It's very Platonist in its essence, that the essence of nature is mathematical. There is one big symmetry out there, and that symmetry is beautiful, and beauty is truth. And hence, there has to be that sort of idea in nature as well. And a lot of people, including Einstein spent 20 years of his life looking for this theory of everything, this unified theory. And of course, he didn't find it. I went to grad school trying to find it too, right? And after many years doing this and talking to lots of my colleagues, I came to the conclusion that that's impossible. That the theory of everything is an impossibility as a matter of principle. And the problem is this, is that the way we understand the world, and interrupt me if I go on for too long.
No, it's good. We're with you.
The way we understand the world is very much based on what we can see of the world, right? Science is based on measurements and observations. And the notion that we can actually come up and have a theory that explains everything assumes that we can know everything, right? That we can go out and measure everything there is to measure about nature and come up with this beautiful theory of everything. And since we cannot measure all there is to measure, since our tools have limitations, we are definitely limited in how much we can know of the world. So you can even build a theory that would explain everything that we know now, but then 2 weeks from now, someone else will come and find something new that does not fit in your theory, and that's not a theory of everything anymore, because it doesn't include everything that can be included.
And I mean, the implication of that is this sense that there would be some apprehension of reality of the universe, which would be perfect. It would be about stasis and perfection. But the way you're seeing it now is more about the universe being about change and transformation and our knowledge, and that being the state of things.
Yes, that's true. So the idea, when you look out, right, into the nature, everything is in transformation at all times. And we see this at the very small, and you see this at the very large. When you look at the whole universe is expanding, it's growing, it's changing in time. And so to me, I look at things much more as a state of flux, of becoming, of transformation, as something that has some static truth behind it. Let's put it that way. And so the notion that we as humans could come up with a final answer to the mystery of nature is, it's pushing things a little too far for our capabilities, let's put it that way.
And Marilyn, in absence of mind, I mean, you're saying many things, but I think to simplify, one thing you're saying is that modern people don't understand how thrilling and rich science is now, and that culture has an antiquated view of science's place.
Mm-hmm. I teach graduate students, I teach highly educated graduate students, and I find that their level of understanding of science is pretty abysmal. And I wonder what it is that makes a culture that really creates its fate and its future, basically, out of science, is not telling people. The thing about science, contemporary science, is that it is as profound in its revelation, certainly, as Galileo ever was, or Copernicus, The fact that we can know things that absolutely revolutionize previous models of the universe we inhabit. I mean, this amazing expansion into the microcosm, an expansion into the macrocosm, all these things that are happening are extremely beautiful, and they are an enormous mirror of the competencies and the aspirations of the human mind. And I think, how are we letting people miss out on this? Just the aesthetics of it.
Mm-hmm. And the nub of some of the difficulty you describe as this far too simplistic choice that I think people, maybe Americans in particular, have felt that they had to make between an idea that the universe is created or the idea that it is all some kind of cosmic accident.
Well, as far as the scale of what we're learning to know, the psalmist has better intuitions about it than Richard Dawkins. But we're pious toward science. It does, in fact, criticize itself and overturn itself. It deserves that reputation. But this strange little world that we're presented as being scientific isn't. It's some sort of petrified conception that would have been at home in the 19th century.
Do you have any...
I actually, being a scientist, I actually agree with Marilyn. I think that once you adopt that there is only one way of understanding the complexity of things, you're just emptying humanity of its value, of the plurality of visions. And so, yes, science is powerful. I love it. I do it. But there are other ways of knowing, and to say that there is only one way of understanding the mind, which is a topic that Marilyn talks so much about in her book, is just silly, to be honest. It's impoverishing the richness of human culture.
I'm Krista Tippett, and this is On Being. Today, in a public conversation with Marcelo Gleiser, a physicist at Dartmouth College and a poetic writer about science, together with novelist and essayist Marilynne Robinson. I also want to talk about this idea of creation and of myth, because, Marcelo, you are not a religious person. Marilynne, you are certainly someone who, well, you preach and you teach the Old Testament, and you are a big defender of John Calvin.
You summed me up.
So, let's talk about creation and the word myth. I think both of you have a real reverence for this kind of language and these ways of knowing, even though you might assess them differently.
Well, I think that if you look at, for example, the first creation narrative in the Old Testament, it's pretty amazing as an ancient account of creation. The fact that, it's perhaps overstating the case, but better than anything else, it does anticipate the modern cosmology, the creation of something out of nothing, which might be mythic language, but very close. We can't do much better than that, I think. It describes the emergence of the cosmos and of life in the world in stages. They don't exactly line up with ours, but still, that's an interesting insight.
It's almost an evolutionary account.
It's almost evolutionary,
Yeah.
Exactly. The second creation narrative, which is the source of a lot of trouble, actually is understood as a fable or a midrash or whatever you want to call it, as early as the writer Josephus. And that's what I think it is properly to be understood as. But in any case, the idea of the abrupt emergence of something fantastically beautiful and intricate is descriptive. And, people can use the language that would call it myth, and I think that myth is the expression of the intuition of cosmology among ancient people. They didn't have, of course, or perhaps would not have chosen to have the kind of language that we use for these kinds of things. But the general perception or intuition that you find in many ancient cultures, so far as I know all of them, that there was a beginning. Even Hesiod describes a beginning. That's a profound intuition that did not burst upon modern scientific sensibilities until Erwin Hubble, until the 20th century, So you have people like Einstein and Bertrand Russell and so on who thought there was no reason to imagine that the universe had ever had a beginning
Bertrand
at
Russell,
all.
you quote him, the idea that things must have a beginning is really due to the poverty of our imagination.
Exactly. And who knows what this means, that human beings had a profounder intuition than science could confirm into the modern period. But you have to respect it. There it is.
Right. So I actually wrote a book way before this last one called The Dancing Universe, and from creation myths to the Big Bang. And what I do there is I look at all sorts of different creation myths from cultures around the world and different times in the ways they dealt with the question of creation, the question of the origin of the world, which to me is the most complicated question you can possibly ask, right? So I call it the question. Right? So then I go and I looked at cosmology in 20th century before we had data. And what happened? All the models, the theories that cosmologists used to explain the universe reproduced these mythic ideas. So there was a universe that was cyclic, just like the dancing of Shiva. There were universes that, at least on paper, were created out of a moment in time, which was Friedman came up with his model in 1922 before Hubble confirmed it, right? And then there was an eternal universe as well. So to me, what's really remarkable is two things. First, that all of this shows how we want to know, right? I mean, the unity here between the two sides, if you want, is on the questioning, on we need to know our origins.
The two sides, religion and science, you mean?
Yes, the mythic narratives and the scientific narratives, they're both asking the same question: where did everything come from? And then, of course, before data, there was also the universality of human thought, if you want. Like there were certain ways in which there are only some ways in which you can answer this question. And the scientists repeated them until, of course, data came. And only in the 1960s, we were finally able to kind of discern that, the Big Bang, meaning there was really a moment in time, seems to be the best way to describe what we see.
To begin to speak of beginnings, to use that word in a scientific way. I don't know, when I was reading the two of you about this, it was the first time that I found myself wondering, why is it that we are so obsessed with the question of beginnings and origins? I mean, I wonder as a novelist if you have a thought about that.
Well, I think, frankly, that as modern people, we struggle under certain prejudices against ourselves, that there are ways in which we have lost contact with, the earlier intuitions that actually describe themselves in culture and literature and so on. But I think, everyone wants to have a narrative of personal origins. Most of us want to have narratives of what you might sort of call tribal origins, where did my grandparents come from and why, and that sort of thing, I think that our bond with humankind is felt as a sort of very much enlarged family narrative of origins in that sense, in some sort of feeling that if you know where you came from, you would know who you are, you would know what you should do. We lack definition of ourselves, which is an incredibly haunting feature of human life. And I think that often if you look at these narratives like the Epic of Gilgamesh or something like that, so it says things about who the gods are, what the purpose of human life is, and so on. I think these are questions that people crave, and they take them right back to primal origins.
Marilyn, you struggle a bit, I think, with science. You have a sense that that even when people didn't have the science that we have now to think about the universe, we had this ancient intuition of our part in it. And is science at play in diminishing that? Is it cultural?
Well, I think that what we think of as science or modern science is something that puts into eclipse other forms of thinking that were also efficacious. Richard Feynman has written, I read an essay of his in which he talks about identity. And he says, it's so amazing that I experience myself as myself over a year of time, that I retain memory and so on, when every atom in my brain would have been changed. Mm-hmm. But you can find the same statement, almost syllable by syllable, in John Locke, who's writing in the 17th century, who says exactly the same thing. Every atom in my brain would have changed. And the question is, how did John Locke know that? I'm very, how is it that the Islamic philosophers that Maimonides was in conversation with were able to quantize time, essentially, as a way of solving the problem of time? How did they do that? How did they know? I think that a great deal of what we do scientifically in the modern sense is actually the confirmation of kinds of thinking that we either received traditionally or would have arrived at by other means. And I think that, I'm very interested now in trying to see how people thought before they had this word science descend on the conversation in the form that it does now.
Right. I think it's impossible to separate us from nature. So when you go to the stories of creation and the relationship or the attempts at explanation that they're really a pre-scientific mode of dealing with the unknown, right? I mean, these people must have been completely baffled by existence, just like we are.
Right.
Right? And we looked out and we see, how is it possible that there are these regular cycles in nature, like the sun coming back every day, the seasons, and then there is a volcanic eruption, there is a terrifying total eclipse of the sun. You know, how do you have regular and irregular things going on in nature? Who is in control of that? And so, to me, those preliminary ways of making sense, of making meaning, were just attempts at trying to have some level of control for things which were way beyond people's control. And science is just the new incarnation of the same sort of effort.
I'm Krista Tippett, and this is On Being. Today, The Mystery We Are, a public conversation with Marilynne Robinson and Marcelo Gleiser. Marilynne Robinson is an author of acclaimed novels. She's been talking about her fascination with the echoes she hears back and forth between modern science, religion, and the arts across the ages. Marcelo Gleiser is a Brazilian-born physicist who's captivated by the beauty and mystery at the heart of scientific discovery. He's also the author of poetic books about science, including A Terror at the Edge of Creation. Here's a line that you wrote, Marcelo, that is the kind of statement that you're making as a physicist, but it's also just a statement about being human, all right? Symmetry may have its appeal, but it is inherently stale. Some kind of imbalance is behind every transformation. I mean, you could be talking about the cosmos, and you could be talking about me yesterday, right?
Yeah, absolutely.
Yeah.
So in this book, I was having the very humble mission of trying to create a new aesthetic for physics. So basically saying that we need to look at the imperfection if you really want to get at things, and give up the notion that there is this beautiful perfection behind everything. You know, the modes of description that we use are fundamentally incomplete. And so let's embrace the imperfection, you know, what's not perfect. You know, I was trying to say, do not try to make science into God, because truly that's the idea, right? This notion that there is this oneness, perfection that you can describe through science is basically trying to create a scientific model for God.
You know, Marcelo, you make this kind of provocative observation that with the search for the unified theory, science has set up a parallel to the God of the gaps, which was the problem, especially in the 20th century, this idea that God began where our scientific knowledge ran out. And you're saying that now the reality is that unified theory begins where our scientific knowledge runs out.
Well, so the God of the gaps is a notion that is old, right? In the sense that even Newton had to use it, because when he was talking about how the planets went around the sun, the question was, what gave the initial impulse for the planets to move around the sun? So he invoked God. God was a very, very important presence in the Newtonian universe. And so this whole idea of trying to put God where we don't understand the world is a terrible idea. I think it's theologically a very bad move, because science will advance, you know, and you will learn more and more about the world. And then God will be squeezed out of this gap and then have to go to another gap. But the thing about this, where does this unified theory need comes from? That's what always mystified me, even though I was a convert in the beginning, you know. And I think it really is a byproduct of having lived with monotheistic faiths for so long. So culturally, it's very enticing for science to come up with this one explanation of everything. And I really trace the roots of that through monotheistic faith.
I wonder what questions you might have of each other.
Well, let's see, Marilynne. So you speak so eloquently of the need for diversity in understanding things. Maybe you can talk to us a little bit about that, and you know why this kind of one way, one track of science is misleading us?
Well, my first criticism of that version of science is that I think that it does not at all describe the best the science does. First of all, because science its genius is self-criticism. When you find out that the universe is accelerating in its rate of acceleration and so on, this is not supposed to be true, and the moment that they find out that all major assumptions have been overthrown, there's rejoicing in the scientific community, and that's a lovely, that is the authority of science for me. The fact that we cannot be articulate about ourselves, and I think that's deeply true. I think that the arts are our effort to articulate the experience of self and mind and so on that is inaccessible to scientific description. That deep yearning that is as ancient as the desire to know where we came from and the rest of it has been disallowed as a legitimate part of the human record and the human conversation. And this seems to me to be completely arbitrary. And along with, of course, other forms of the profound self-exploration of human inwardness is the rejection of religion, which is also put out of account. There's nothing really more universal, I think, in human cultures than the impulse to religion. If you were looking at it dispassionately, the question of what people are, you would have to take this very enormous and elaborate self-description seriously as a datum, so to speak. And I think that if people have interests that are scientific but don't tend toward addressing questions of that kind, fine, they've distinguished themselves, it's beautiful. But they can't act as if they have addressed those questions when, in fact, everything that they do is actually relevant to another set of issues.
I think you're actually saying that to dismiss that very ancient and pervasive aspect of human life and human culture is irrational on some level.
Yes.
Yeah, and to think of science as separate from spirituality, to me, is a big mistake. There's nothing that says that science should be dispassionate about the spirit or the life of the spirit. And to me, it's quite the opposite. It's exactly because I feel very spiritually connected with nature that I am a scientist. And to write equations on a blackboard and to come up with models about how the nature works is in a sense a form of worship of that spirituality. And I feel that very concretely all the time.
Do you have a question of Marcelo?
Oh my. One thing that I find when I'm reading, scientists that write in a popular way, write in these issues, and that frankly I found a couple of times in your book, is a tendency to use the word explain when I would say the appropriate word is describe. If they figure out the fine points of photosynthesis, maybe you will say, well, it's a quantum phenomenon or something like that. That's a description. It's not an explanation, And perhaps there are things that are not, don't make themselves available to explanation. But that does not mean that description stands in the place of explanation. It's sort of like if somebody says, why does a clock tell time? You can describe the mechanism of the particular clock. Or you can say, people arrived at a convenient definition of one day, divided it into arbitrary segments, and made a mechanism that would measure those segments because culture required timekeeping with that degree of precision. Now, that's not a complete explanation, but it is explanatory, whereas the other one is only descriptive. And I think that's a very important distinction that is not made, because very often when people look at religious accounts of things, people looking at them from the outside, they say, no, that's not an explanation. Actually, the explanation is that it was beneficial to the leopard's existence that it blended into a shadowy landscape, hence spots. You know what I mean? This is descriptive. It is not explanatory.
I'm fine with that. I mean, I think that I don't think I have any claims there. I would say that we are just trying to make sense of physical reality in the best way we can, and perhaps what you are implicitly referring to is the lack of humility that sometimes comes with the scientific kind of rhetoric. That there is sort of this like, this is how it is kind of thing. And the ones that probably bother you the most are the ones that get the public voice and that do make rhetorical statements about things such as, now science can understand the origin of the universe, which is absolutely not true, formally not true, But the statement comes out in the media and in books by very famous people all the time. And that bothers me as much as it bothers you.
Well, somehow it's in the nature of media and our public dialogue that it's not the humblest voices of religion or science who
that is so true.
Make their way in front to microphones and cameras.
That's
That
right.
here you are in front of a microphone.
Right.
I'm Krista Tippett, and this is On Being. Today, The Mystery We Are, a public discussion with theoretical physicist Marcelo Gleiser and novelist Marilynne Robinson. Here's a line of Reverend Ames in Gilead. This is an interesting planet. It deserves all the attention you can give it. Just before we finish, let's talk a little bit about mind, which takes us a little bit outside the realm of physics, but very much into your writing, Marilynne. Mm-hmm. And somehow the primacy, the centrality of our minds, the power of them, even in all of this discerning of distant galaxies.
Well, I think one of the things that is fascinating is that we don't know who we are. Human beings, in acting out history, describe themselves. And every new epoch is a new description of what human beings are. Every life is a new description of what human beings are. Every work of science, every object of art is new information. And it is inconceivable at this point that we could say anything final about what the human mind is, because it is demonstrating, in beautiful ways, in terrifying ways, that it will surprise us over and over and over again, And if I read something that seems to me, I mean, we have mind in two senses, or several senses, but one of them is the sort of the individual striving mind. I want to come up to the mark. I want to follow my passion. I want to let myself think about something that seems beautiful to me. There's that mind. And then there is the larger collective mind that somehow or other seems to sort of magnify impulses and so on that occur among us individually. When you think how even the most brilliant people living, in the first century would see how we know and what we know now and so on, which is basically a pure elaboration of what they'd already started. Nevertheless, they would be completely astonished. They would say that human beings could have done such a thing, We know things about our minds because we've seen them reaching and unfolding in this uncanny way that they do. And I just think that undervaluing mind, it distorts what we're capable of, But I don't know. That's what I think. I think the mind is fantastically competent and beautiful and, in a very large degree, unexplored.
Marcelo, is this new frontier of mind and consciousness, is it challenging for physics? Or where does it fit into your way of seeing the world?
It's very challenging because the way physics traditionally has worked is through this reductionistic method, right? You look at a complicated problem, you break it down into small parts, you understand how these small parts work, and then try to make sense of the whole. And this extrapolation works beautifully when you're talking about stars and galaxies, but it really fails miserably when you're talking about the mind or the brain, right? So as I said earlier on, you can't understand the brain by understanding how a neuron works. And so it poses a tremendous difficulty for physics because we can't model the brain, right? And physicists, that's what we do for a living. We make models, we test our hypothesis. And we need a different kind of explanatory descriptive tool because the way we have dealt with things just won't work for the brain. So what would that be now, right? So there's this whole new notion that comes from complexity theory that the mind is an emergent phenomenon that we can't quite explain, that has to do with the concatenation of many different groups of neurons at the same time. So the interesting thing about that is that if that is true, then new laws will emerge at different levels of complexity. And you can't go from one level to the other level directly. You really need a completely different kind of explanation. And we're not there yet, but it's just an alternative way of thinking about how the brain works. And to me, given the complexity, even if we go there and we gain some level of understanding above what we know now, it's always going to be incomplete, just like Marilyn said.
But I think that part is exciting for you. The fact that it will be incomplete, the fact that there will always be more to learn.
Yes, when I was saying this, I was thinking, can we ever build a machine that thinks? Right? That's really the question, right? Because if you could build a clock that thinks, right, then you'd really say, yes, we mechanize the brain and we understand exactly how it works and what are the rules that make it all make sense. But I am a skeptic when it comes to that. I really am, at least for the foreseeable future. I don't see how even increasing the power of computers will be able to do that. What we will be able to do is what the internet is already doing, which is creating an enormous data bank of information that will almost look intelligent. But you will always be asking the questions. You know, it's the asking of the question that is the mystery, not so much how you find the ways to answer it.
I think that's a wonderful thought, that the asking of the questions is the mystery. It occurred to me when I was reading both of you and thinking about this conversation, how much a novelist and a scientist, a physicist, have in common as creators and discoverers.
I'm flattered.
So am I. I mean, novelists create universes, right? Talk about a multiverse. You know, the mind of a novelist is a huge multiverse because they're creating all these different dynamics and people that don't exist. So in a sense, you know, you are playing with inventing lives and minds and stories. So you are amplifying the mind every time you do such a thing.
Yes, there's the problem of plausibility, you know, making what it even appears to be a sort of working model of a human personality is such a delicate thing.
I'm sure, you know. Yes, how is it that you say that fiction is it's telling lies, but want to make sure they sound like true.
Exactly.
Right? So, and that's, we're trying to do something similar. We're trying to make models which are never the whole truth of nature. That is a fundamental point. Every model is a lie, but some models explain more than others.
Mm-hmm. I tell my students, actually, that the mind continuously creates hypotheses. You know, tomorrow is a hypothesis. You have some theory of the general shape of tomorrow, which could be completely false, completely inaccurate. But you have to have the hypothesis in order to be sane and act rationally in the world and so on. And when you're writing fiction, you're doing something of the same kind. You know, or when you're making a scientific theory, you're doing something of the same kind. This is the best model I can create of what this reality would be. You know, and in fiction, unless the fiction fails, the hypothesis does not get exploded, but at the same time, you always understand its hypothetical nature, you know. Whereas in science, the hypothesis is floated and retrieves what it can and explodes if it needs to, you know.
Do you feel when you write and you create characters, do you feel like they drive you in a certain way?
Absolutely. And thank God when they do.
Because we do too. When you're working on a technical problem, it seems to have a way to go, that we're not always in control. We're just making sure all the minus signs and the plus signs match.
Wonderful.
But it really has a way that it wants to go, which is kind of beyond what we have total control of.
That's fascinating. It is.
And when you find a solution or something that looks like a solution, you get emotionally moved to an amazing extent, especially when it's a surprising thing. It really is a spiritual emotion. Like I've had this a few times, not many. Einstein probably had it several times, but I just had a couple. But when I have this, it really is something transcendent.
Do you think that, for example, teleology might be an inadequate way of articulating what you're talking about? Teleology is sort of forbidden, but you can feel the shape of something pulling you towards something that you don't intend, and it's as if the shape is somehow intrinsic and the conclusion is somehow necessary.
It's funny because you phrased it in the negative. So that's very smart. I am always afraid of teleology. Teleology has so many different traps. And so the question is always, if it's teleology, who's in control? And I don't know.
Exactly.
Who are your characters that are driving you?
Yeah.
Right?
But you don't know who's in control, and you have the feeling that there is some sort of intrinsic control emerging in the sense, for example, that if you're creating a character and you ask him to do the wrong thing, use the wrong language, or leave when the conversation isn't over, he refuses, And I'm sure that when you're doing something like that, you take a wrong turn, and it tells you it's a wrong turn.
Yes.
In some way.
Absolutely. You know you're going wrong. You completely do. And that's what's hard about science. I don't know about fiction writing, is that sometimes you're forced to go where you don't want to go, because otherwise you're violating a certain law, And that is just horrifying, right? Because you really want to prove something, but you can't, because it's wrong. And you really believe in it, but that's not good enough, right? And that's the sort of the ruthless aspect, of science, in the sense that I don't know, maybe as a fiction you have a little more freedom, than we do in that sense.
Or another kind,
So, I think in a very remarkable way, we've ended up back at the mystery of creation and even wandered into free will, but we don't have time to go there this evening. So I want to thank Marcelo Gleiser and Marilyn Robinson and Templeton Foundation and Center for Theological Inquiry for hosting this. It was lovely to be here. Thank you.